Hello all and welcome to my YouTube channel. So today we are going to see an end-to-end project which is built on an multi-agent capability, and as from the name you can see on my screen, we are building a SupportX AI Assistant, which is a IT support assistant tool, and we have integrated this tool, or we have built this tool with the help of an multi-agent capability. So we have used open source AutoGen framework, which is developed by Microsoft, and this framework will help us build a multi-agent functionality. And behind this particular tool, there are multiple agents that we have built in order to identify the user issue, categorize that, and then give the resolution for that particular issue. So without wasting time, let me give you the demo of the application first, and then we can go ahead and see how we can build this particular tool end to end. So we'll be writing end-to-end code. We will be writing each and every module, and also I'll let you know what and all services that we are using. So yeah, let's go ahead and ask our questions to this particular tool. So let's say as a developer, let's say I'm facing issue. Let's say my Outlook is not working. So I can elaborate my issue here. Let's say my Outlook is not working. It's getting closed frequently. So this is the issue that user is facing. Let's click on resolve now. So now it is going to call an multiple agent that is available behind this, and then it will find out the best resolution. So we have already created a vector store where we have put in some past incidents that are happened with the developers. Based on that, it will suggest some resolutions. Okay, you can see it has generated the response. To resolve the issue with Outlook crashing frequently, try running Outlook in safe mode by typing this particular command. And if Outlook runs smoothly in safe mode, the problem may be due to add-ins. You can disable your add-ins one by one and to identify the problematic one. So, and then it has terminated, and then it is asking, was this solution helpful or not? So what user can do, user can go ahead and try it out this particular command, can disable the add-ins, and then if the issue is resolved, user can come back and say yes, issue is resolved. If issue is resolved, then great, we are glad your issue is resolved and thank you. Bot ends the termination or ends the conversation. Now what happened actually in the backend is it has called two agent. First one is the classifier agent. Based on this issue, it has recognized what is the type of this issue. So we have different types of issue like network issue, software issue, hardware issue. So this belongs to, let's say, software issue. There is some problem with the software. So it is categorizing that. The task of first agent is to classify the type of issue. So we have a classification model which is classifying this. Next, we have a knowledge base agent. So we have a vector store. We have used Azure AI search as a vector store. In that, we have already recorded some past incidents that are happened with our IT support team. So with the help of our IT support team, we have collected those whatever past incidents, and then we have categorized them into, we have well categorized them into different categories, and then we have given their resolutions as well. So second agent is hitting to our knowledge base, that is vector search. So for second agent, we have enabled a tool capability. So with the help of tool capability, it is hitting to our custom Azure AI search database. From there, it is finding the most relevant matching result for this particular query that user is facing. My Outlook is not working, and then whatever resolution that was done at that time which was working, it is giving that resolution to the user. That way user can get to know that, okay, user can try it out those methods and see whether issue is fixed or not. Now sometimes it may happen that, okay, your issue is not resolved, then you need to go ahead and raise that ticket to the IT support team. So in that case, what will happen is your bot will raise, or this particular tool will raise that incident. It will create that ticket and send out that ticket to the support team. So it will take care of those issues which are not resolved. And then later on, those issues we can again keep adding into vector store. That way we can grow our knowledge base database as well. Now let's try it on another example. Let's say, I don't know why, but my mouse is not working. It's operative when I connect to my personal laptop, let's say. And let's click on resolve now. So again, it will go ahead and hit to the different agents that we have, and it will bring the solution for user. So let's wait for that solution. Okay, now you can see the issue with your mouse might be related to the battery or USB connection. If it's wireless mouse, try reconnecting the dongle or Bluetooth, and this should help resolve your problem. But yeah, okay, as I already mentioned, that mouse, when I connect to my personal laptop, it's working, but it has given this solution. User can try it out this solution. User can check this dongle if it is working or not. And let's say in our case it is not working. So instead of clicking to yes resolve, now we can click to no, not helpful. So as soon as we hit not helpful, you can see we are escalating the issue to IT support team, and this particular ticket is created with this ticket ID. So it has created the ticket dynamically, and you can see notification agent response that email has been sent to the IT support team, meaning you no need to worry now. Like everything it has taken care of. It has created a ticket on behalf of you. Also, it has sent out that email triggered to the IT support team. Now your IT support team can look into that issue and come back to you. Let me show you the email that we have sent. So let me refresh. Okay, you can see we have received this particular email. Escalation unresolved IT issue. You can see we have received it 0 minutes ago. Hello IT support team, the following issue reported by the user could not be resolved by the AI assistant, meaning our AI assistant could not help. And that's where it is an unresolved IT issue. And user reported, I don't know why, but my mouse is not working. It's operative when I connect to my personal laptop. And this is the ticket ID. Please investigate and take further action. AI notification agent. It has written this beautiful email. It has sent out that email to the IT support team. Plus, it has created the IT ticket ID as well. Because you know that in your organization, your support team doesn't work without ticket. They need ticket in order to fix your issues. So that is how it is reducing the overhead of your support team as well, because it is creating the ticket. Also, it is fixing most of the issues at developer side, because most of the knowledge base that we have created will be able to help fix your issues, because most of the issues are common in support team, right? That way your IT team no need to come and help you, support team no need to come and help you again and again. This bot is helping, or this tool is helping them to fix the issues at developer side. And second, it is helping from developer side as well. Developer no need to wait for the IT support team to come back and help fix that particular issue. Instead, they can come to this particular tool. They can get a quick resolutions. They can try it out those resolution. If it's working, most of the time which will work, their issue is fixed. They are good to go, and they will their productivity will be improved. And also, if the issue is not fixed, then you developer no or user no need to raise the ticket manually. The tool will take care of raising the issue, and developer can work on their other things. So, and also the support team, again, it's a costly operations that the companies are running, and this definitely help reduce that particular overhead to the companies as well. So from all the perspective, it is improving productivity, it is reducing cost, and helping to the organization. So very great tool that, and you can definitely use this as your resume project. The code will be available in the GitHub. I'll drop that link down in the comments in the description. Go ahead and check out that. Definitely put these particular projects into your resume, because this is the first multi-agent project that we have built after covering our AutoGen playlist. And if you want to check out the AutoGen playlist, that link also is available in the description below. So where we have covered all these functionality, how we can build this group chat functionality of multi-agent, how we can integrate a Azure AI search tool, everything is covered. Please go ahead and check out that. Now, as we have seen this, let's get started with the coding part, how exactly we can build this. But before coding, I would like to show you the architecture, because every project, it starts with architecture. You need to define the architecture first. And that's where I'm telling you, this is the real-time project that we are covering, where we are covering from very scratch. So first, now we will see the architecture. In the architecture, we'll see each and every detail. What is the flow? When exactly it is calling what agent? How we can create the vector store? Everything we'll see, and then we'll build that code by writing module by module. So I'll be writing whole code in front of you, and then we will be executing that. So please stay with me till the end of this particular video. If you are really interested in building the multi-agent related framework, please stay back. So let's get started with the architecture. Okay, so let's take a look at our architecture diagram. So this architecture diagram is categorized into three different types. First, we have the support assistant UI. So this is our UI part, where we will be building this user interface with the help of Streamlit application. And then the second part is the multi-agent framework, where we have three agents: notification agent, classifier agent, and the knowledge base agent. And third part is the tooling, that is our vector AI search, where first we will be creating this particular index, and then we will be accessing the created index. So how exactly it starts? Whenever user asks the question, so this is our user query. That user query first goes to the classification agent. Now this classification agent, again, it is a LLM powered agent, which has several information, like it categorized your agent into, it categorize your issue into different categories. Let's say you have categories like network issue. Then your second category is, let's say, software issue. And let's say your third category is hardware issue. So whatever issue that user is facing, it is first categorizing it into these categories. There are few more. We will see those categories whenever we'll see the actual data. So that's the task of classifier agent, in order to add one filter at the top, identifying the network category, so that our AI search or the knowledge base search becomes easy. Then it pass that response to knowledge base. Now the task of knowledge base agent is to take that particular category information along with the issue. So it will pass, let's say, if the issue is, let's say, network, it will keep that, and along with that, it will pass the other information, the description of the issue. And that information it will pass to the knowledge base. Now, knowledge base agent, first, it will find out the top matching queries that are available in the vector store with respect to network, and that is matching with this particular description. So here first there will be different queries that will be available and embedded into the vector store. So first it will filter based on network. It will find out the network related problems, and from that network problem then it will do the match based on the description, and it will pick the top first record. That top first record, so here you can see we are pitching the top n record. That first record, then it will be sent to the notification agent. And then this notification agent, again, it has a tool capability, which is connecting to this email sender tool. And first it will check, okay, it will identify that particular record. So first it will take that particular record, it will generate the email, and then it will send out that email. So this particular third agent is responsible to send out that notification to the support team. That notification will go to the support team, and that we will be seeing on the SupportX assistant, whatever ticket that it has created. So first here it will create the ticket. Here it will create ticket ID, and that ID it will then pass it to the SupportX UI, or it will pass to the IT support team. So that's how the complete framework will work. The below one we call it as multi-agent framework. This one because it has three agents. First one is the classification agent. This is our classification agent. Second one is our knowledge base agent, and third one is our notification agent. So these three agents, that is where we call it as multi-agent framework. So that's how the particular flow works. And as we all know that now agent has the capability to take reactive action. So whenever user's query is not resolved, it is also taking action by sending out this particular email as well. So that is where it is different from the normal chatbots. The intelligent IT ticket resolver or SupportX assistant is not only responding to the user, but also it is taking action on user's query. So if the query is not resolved, then it is raising those ticket as well and sending those details to the IT support team. So I hope this part is clear. This little part that we have here is to create the vector index at first time. So whenever we are first time we will be having this particular data where we will be having a JSONic object where we will have, let's say, network category and the description. Then again we will have second category and the description. So this is how we will have the data. And this data then we will pass it to the particular embedding. It will embed the data. Here we will use our model, text embedding model. So first we will use text embedding model. And this text embedding model, again, we are using it from the OpenAI text embedding model that we are using. And then for these agents, we'll be using GPT-4 as a base model. So all these agents will have LLM capability with GPT-4. So that is the model that we will be using. So two models we need to deploy on Azure, and also we need to deploy this particular Azure AI service. So this is our Azure AI search service. That is what we'll be deploying. So yeah, I hope the architecture is clear to you now. Now what we can do is we can go ahead and start writing our code model by model. So yeah, please stay with me and we'll build a complete solutions in one go. So let's get started with our code. Okay, so we have opened our Visual Studio Code, and this is the IDE that we'll be using to complete our coding. So let's get started. We'll write each module by module. So first of all, let's go ahead and create the new virtual environment. Okay, so for creating the virtual environment, let's create a new terminal. So I have selected my command prompt. Let me just zoom in a bit. Okay. So in order to create the virtual environment, we can use Python -m stands for module. VNV is our virtual environment that we because we are creating virtual environment, and name of the virtual environment, that is VNV I am giving. So let's create that. You can see it has started creating this particular module VNV. So let's wait for the completion. Okay, you can see it is completed. In order to activate, we need to go inside script and we can execute this particular activate file to activate. So let's go inside VNV scripts. We have activate. Okay, you can see virtual environment has been activated successfully. Okay. Now let's create a requirements.txt. That is what is going to be required. Then also let's create .env in order to store the secrets. Okay. So these files are created. Let's start writing our code. So first of all, let's write our first code. So basically user agent we need to create in order to, because whatever entries we are passing, it first goes to the user agent. So let's go ahead and create one file, agent test.py, where we will be testing our individual agents. So here, so from AutoGen, let's import the proxy agent. First of all, let's go ahead and install the AutoGen. So in the requirements, we need these many requirements will be required. AutoGen python.env in order to read the secrets, OpenAI and AutoGen. Right. So let's go ahead and install that. Install -r requirements.txt. So I'm using latest Python version. I think I'm using 3.13. So you should also use latest Python version. And ideally try to use the Python greater than 3.10 in order to make sure that your code works smoothly. Let's wait for the requirements. Meanwhile, we can go ahead and start writing our agent test.py. So first of all, we need to create the user agent. So creating user agent is very simple in AutoGen. You can see we have imported user proxy agent from from AutoGen. And let's write this particular simple function, get user get user agent, and user equals to user proxy agent. Name is user. Human input mode never, and code execution false, because we are not executing any code and we are just returning the user. So simply we have created one agent. So that how easy it is to create the agent in AutoGen. If you have if you are new to the AutoGen, I would recommend go ahead and check out the playlist where I have covered all these details, because this is the extended video in the same playlist where we are covering end-to-end multi-agent project. So check out that, link is available in the description below. Now, as the user agent is created, we can test this agent as well. But before that, in order to test, first we will need two agents. Now we have created user agent. Second, we can create a classification agent. So as we have mentioned here, first query goes to classification agent. So first it goes to, you can see user issue. The user agent picks this user issue and then it checks with the classification agent. So in order to build the classification agent, what we can do is we can go ahead and create separate modules. So let's create agent module. So first, let's create agents as a tool, as a folder, and inside that we can create classifier agent.py. And here we can define that agent and we can call that particular agent into agent test in order to test that. So again, let's import the necessary dependencies. So we will need pathlib, OS and pathlib in order to read the path. And then from AutoGen, we are calling assistant agent. The first type of agent that we have used is the proxy agent, user proxy agent, which is going to act as a user. If any execution task is there, let's say if you want to execute any tool, any code, then that goes to the user proxy agent. Then we have assistant agent. Assistant agent is to assist the user agent with the queries. So first query will go to classification agent, where this assistant agent class will help us classify the object. So simply we can go ahead and write the classification agent. Again, a very simple code similar to the user proxy agent. We can write get classifier agent, and agent class we can write assistant agent, and inside assistant agent we have given name as classifier agent. Along with the name, we need to give LLM configurations. Now here we need to define the LLM configuration. Now we will be using a GPT-4 model. So first of all, we need to deploy the GPT-4 model. As we are using Azure AI, so we will be deploying our model onto the Azure OpenAI service, and that service we'll be using. If you have your OpenAI subscription available, then you can directly pass your OpenAPI key in the LLM configuration, and that way it will work. But as we are working on a real-time industry project in organization, we don't use OpenAI subscriptions directly because there are chances of data leakage, and organization don't want to lose their data, or they don't want to expose their data to these external application, and that's where they have more control way of accessing the large language model through Azure OpenAI services or any cloud-based solutions that the organizations are using. We are going to stick with the Azure OpenAI service because other services also will be creating in Azure. So first of all, let's go ahead and deploy those services, and then we will come back and fill these LLM configuration detail. Okay, so in order to create the Azure OpenAI service, you need to go to portal.azure.com. That will take you to the homepage of Microsoft Azure. And in the search bar, you can search for the OpenAI. You can see Azure OpenAI service. Let's click on that. So we need to deploy this particular service. So let's click on create. And whenever we are creating this service, we need to create the resource group, because resource group on Azure make sure that all your services that you are using for a particular project resides inside one resource group. So that is the reason we need to create resource group. If you are new to the Azure, I would recommend create one Azure account. You will get a free subscription, like you will get credit worth of close to $200, and with the help of that, you will be able to create these services. Or else you can select pay as you go option. So currently I am on the subscription pay as you go, but you will need an active subscription, either free or pay as you go. So please go ahead and do that. And again, this detailed part I have already covered in AutoGen playlist. So go ahead and check out first video of the playlist that is available in the description below. So you can see subscription. This is the one that I have already, pay as you go subscription. Resource group, let's create a new, and let's give name as resource group RG. RG stands for resource group. That's the industry way of industry practice of giving name. RG stands for resource group. OI stands for OpenAI. Then let's say AI, yes, stand for Azure AI search. Likewise, the organization gives the name. Okay, so let's follow that practice here as well. RG, and then we can give our project name, intelligent ticket. We know that intelligent ticket resolver, but this name is fine. Let's click on OK. Region, you can select East US, that is fine. Name, now let's give name as, again, this is going to be our project one. So, and this is the OpenAI service. So OpenAI service, again, we can give AZOI, Azure OpenAI hyphen intelligent ticket. Let's say this is our name. Right, then in the pricing tier, select standard ES0. That is more than enough. Let's hit next. Keep it open to all network. Hit next. You can ignore the tags. Hit next. It will perform some validation checks. It will check whether this service is available in East US region or not, and whether we have followed the correct nomenclature or not. So yeah, validations are completed. Let's go ahead and hit create. So this will take a 15 to 20 seconds in order to create this deployment. So let's wait for that. Okay, you can see the resource has been created. So you can hit go to resource. That will take you to the OpenAI resource that we have created. You can see EasyOI intelligent ticket. And in order to go to the Foundry portal, you can either click on here or you can go from here. Now, what is Foundry portal? So Foundry is a service provided by Azure where all our AI related resources are accumulated. So if you want to learn about Azure AI Foundry, then I have prepared a Udemy course. The link is available in the description below. Please go ahead and check out that. So basically, it's a service where all our LLM or AI related services are available. So you can see we have assistant service, then we have, let's say, fine tuning of LLM is possible. Azure OpenAI evaluation, model evaluation is possible. In the models section, we can create models as well. So if you see in the deployment sections, we can deploy our GPT-4 models or any other open source model that you want to deploy. In the model catalog, you can see what are the different models that are available. You can see these many models that are available, and we can consume these models. And so yeah, you can process images, you can process audio, video, all those AI related services are available in Azure AI Foundry. So let's go ahead into the deployment and deploy model that is required. So we will be requiring two models, GPT-4o and text embedding model. So first let's go ahead and click on base deployment, and here let's select GPT. We'll be using GPT-4 model. You can see GPT-4, no, not this one, GPT-4 chat completion. This will serve our purpose. In the deployment details, you can click on customize and you can reduce the number of tokens to 15K, because these are more than enough in order to accomplish our task. This is just in order to save your cost. And then you can click on create and deploy the service. So this will hardly take 4 to 5 seconds in order to deploy this particular service. So you can see the model has been deployed, and these are the model endpoint and key details available. So you can see this is the model key which we'll be using in order to access this model. And you can see this is the Azure endpoint that we will be using. So let's copy this Azure endpoint, and we can go ahead and add these endpoint details into our environment file. So one thing I would like to mention here, you can see now here the resource is different. You can see this is not the resource that we created. It happened because when I created the model, it created the model into another basically location, because the location that we selected East US, in that region this particular model was not available. And it happens, right, because it's a cloud-based service. So sometimes wherever the model is available for us to use or consume, it creates the service into that. So it has created new service, no need to worry about that. We can go ahead and delete all these services at the end, but yeah, we no need to worry as such. So we can copy this particular project endpoint. Let's go to our code, and first of all we need to write those details into environment file. So first of all, let's add project OpenAI endpoint, and the endpoint that we have copied. So this is the endpoint that we'll be using. Then next we will need the deployment model name. So Azure deployment model name is GPT-4o. That is what we have given. Next, what we need is the Azure OpenAI version. So version is again 2024-1201 preview. I will show you that version as well. And at the end, we will be requiring the Azure OpenAI key. So let's pass Azure OpenAI key as well. So let me show you. So you can see this is the key that is available. You can copy this particular key and you can pass here. This is our key. Don't share your key information with anyone. I am going to delete this resource before uploading this particular video. So make sure that you are not sharing your secrets to anyone. Then you can see this is the model preview version that we have copied, and this is the model deployment name. You can see model name GPT-4. Okay, so we are good now. We have added these configurations. Now let's go ahead into our classifier agent, and we need to define the LLM configuration. Okay, so there is a specific way of defining LLM configuration. Let me show you that. So this is the way with which we can define the LLM configuration. First of all, we need to set the temperature and the config list. In the config list, we need to set the model, the API key, the base URL, type of Azure, and the API type and the API version. So in the model, we'll be reading Azure deployment name. That is the model name that we have given in the environment file. So in order to access that, first of all, we need to load the .env so that we can load the secrets. So if you know, .env is the library which we use in order to read the secrets. So Azure deployment name, you can see this is the deployment name that we have given. And then similarly, Azure OpenAPI key, endpoint, type is Azure, and the API version. Those details are required. And that LLM configuration we can pass here. Once that is done, then we need to pass the system message. So for passing the system message, we need to write a system message. Now this system message is nothing but prompt for this particular agent. So in order to pass that prompt, first of all, let's go ahead and create utility, because we will be storing all these details into utility. So let's create a folder, utility, and in the utility, let's create file prompt.py, and let me copy the prompt that we'll be using for our classifier agent. So you can see this is the classifier prompt. You are an IT ticket classifier. Your task is to classify a given user submitted IT support query into following categories. These are our categories: network issue, hardware issue, software issue, access request, password reset, and any other categories. And we have given some sample examples. We call it as a few shot learning kind of few shot learning technology where we are passing is few examples for our model to understand what exactly the model needs to return. So this is what a model will have to respond ticket and the category. So for example, let's say input I can't connect to VPN, then model should return output ticket I can't connect to VPN and category network issue. So this ticket meaning the original ticket description that needs to be written and category of the ticket based on this. So our LLM has the capability to distinguish. So we have given a couple of examples and that's how we are returning. So this is the prompt. Let's pass this prompt to our agent. So here we can go ahead and load the prompt first. So from utility, we can import prompt. Okay, you can see it is not available because we need to go ahead and create a package for our utility. So in order to create the package, we can go ahead and create a underscore underscore init file. Underscore underscore init underscore underscore dot py. Once we create this, it makes sure that this particular utility folder is now acts as a package. Package meaning, let's say if you are using this particular user proxy agent from AutoGen. So AutoGen is a package. From that package, we have imported this particular class user proxy agent. Similarly, by creating this underscore underscore init constructor, we call it as constructor, we have created utility as a package. Now we'll be able to import the utility prompt from utility. Okay, there is some spelling mistake. Let me go ahead and correct that. Okay, you can see as soon as I have created that, the error went away because now we'll be able to use this particular prompt. Let's go ahead and pass that particular prompt here because we'll be using that particular prompt. Sorry, I think it is not a prompt. I think it is classifier prompt, right? Sorry, my bad. So we don't need to import complete prompt. We can go ahead and from utility dot prompt, we can import classifier prompt, and that classifier prompt we need to pass here. So we are done. Let's close the bracket. This particular agent is ready. Get classifier agent is ready now. Let's import this particular agent into our agent test. But before that, this particular file, LLM configuration, instead of keeping it here, we can go ahead and add that into the utility because we'll be using that file again and again because it is required to add that file to the knowledge base agent or the notification agent. We need to pass the LLM configuration. So let's go ahead and add that file. So in the tools, sorry, in the utility, go ahead and create another file, LLM config.py, and here we can paste this particular file, and we need to, in order to load these secrets, we need a load.env. This will make sure that we are importing the right secret. Now we no need to read the secrets again and again. We can directly call this LLM configuration into our classifier agent. Now in the classifier agent here, let's go ahead from utility .llm configuration, we need to import LLM configuration, and we are done. So this is how we have written the standard code. Now in order to test this, let's go into test agent and we can test the agent. So for testing the agent, we can write function called run test, and inside run test, we can call these two agents that we have defined. So the first one is user agent. This is the user agent, and second one is the classifier agent. Now this classifier agent is available in classifier agent. So let's go ahead and import that. As you can see, again, it is failing. We are not able to import that because again, we need to create this agent as a package. So again, in the agent, let's create underscore underscore init, that is constructor. Okay, so as we have created, now we'll be able to load that. So here, let's close and reopen this file. Okay, sorry. So it is available in agents. So agents dot classifier agent, we need to import the get classifier agent. So that is what we have imported. Now both the agents are available. Now let's create a simple function to test the whether agent is working or not. So we have created the for loop from sample tickets. Let me define sample ticket. So this is the sample ticket. The VPN isn't connected since morning, and we want to test which is the category of this. So our classifier agent should go ahead and classify this particular agent. So currently we have just one agent. So sorry, one issue. So from sample ticket, we'll pick that issue and then we'll start the chat. So this is the simple way of starting the conversation in AutoGen. User.initiate chat. Recipient is the classifier. Who is going to respond to that is the classifier, and then message classify this ticket, and this particular ticket will be passing. And max turn one, after this one turn, it will terminate the conversation. So this is the conversation termination method that we have used, max turns, and this is the initiate chat method which will start the conversation between agents. Very simple. Let's go ahead and write the main function, and here we can define, we can call the run test. Now if you don't know this main function, make sure that this code executes only if you are running this file as a main file, or else it will not run. So if you are calling this particular function in any another package file, then it will not run this particular code if condition. But let's say we write this particular condition in order to test the application or test the module that is working or not. So we have written this particular module and we are going to check whether we are able to classify this or not. So as we have written this, let's go ahead and run this. What actually it should do, it should start the conversation, agent conversation, then it should, this particular issue, it should find out the category based on the prompt that we have given, based on this particular prompt. So let's go ahead and check out that. So in order to run that, we can use Python, and then we have, let me rename, there is again a spelling mistake, agent test. So let's go ahead and run agent test.py. Okay, we are getting an error, none type of attribute. Okay, so we have missed to return the agent here. So this function is not returning anything. So let's go ahead and return this particular agent classifier agent. So that was the mistake. So again, go back, save the file, and let's execute this. Okay, you can see now user has given this particular query. Classify this ticket, the VPN isn't connecting since morning. Then it has given that response to the, so user agent has called the classifier agent to identify the issue. Classifier agent to user return the format, return the response in this format, ticket the VPN isn't working, category network issue. So it was able to categorize. So our LLM connection is working. It is hitting to the GPT-4o model, GPT-4 model that we have deployed on Azure, and it is, with the help of using that model, it is identifying the category. Let's try another question. Let's say my mouse is not functional. Simple query. Let's see if it is what exactly. Now this is a hardware related problem. So let's see whether it is returning the correct response or not. So let's again run the file python agent.py. You can see my mouse is not functional. You can see it has written hardware issue, meaning our model is working perfectly. Okay, so now we have built a two agent, user agent and the classifier agent. So this task is done. From user issue, we have user agent in order to start the communication with classifier agent. So this one connection is built now. User agent, we don't usually call it into the agents because its task is to just replace human or replace the manual activity. But yeah, if that's the case, you can call user agent. You can add one more agent here, user agent, and then you can have a classifier agent. Okay, now once this is done now it's time for us to build the second agent, that is knowledge base agent. Now this particular details that we have fetched, now we need to check for this particular hardware issue. My mouse is not functional. What could be the right output? And in order to find that, first of all, we need to understand what is the data that we'll be using to pass that data or store that data into vector store. So what we will be doing is, in this particular step, we are going to work on this particular step. We'll be creating a schema metadata. We'll be understanding what are the past incidents that are happening in the organization. We'll embed those. We'll create the index and upload that index to the Azure vector store. And then we will pass whatever classifier output was there to this particular AI research, which will embed that output, do the vector search and find the top match record. Let me go ahead and show you the data set. So let's create one folder here. data where we'll be storing our data. And inside that data, let's create one JSON file, knowledge base.json. And this is the data that we have received from our support team. That okay, you can ignore about the ID. Let's say category is password reset. I forgot my email password. Solution, please go to the company login page, click on forget password and follow this step. Similarly, the support team has collected the different issues that the users have faced in the past, and based on those users we have created this data, and we'll be using this data in order to respond to the user. And in order to quickly access this particular data, we'll be storing that into vector store. Now why we need to go for vector store? Because currently, let's say here we have, let's say, close to 15 to 16 queries, but in your real organizations, right, you may be having 1,000 queries or 2,000 queries or more than that, right? And it is not feasible to pass those details into the prompt itself because your prompt has limit. How much? Let's say if your prompt has 8k limit, you cannot pass more than 8k tokens into your prompt, and if you are passing these many information into your tokens, your model will fail. And in order to avoid that, as well as whenever you are processing this much metadata from generative AI model, it charges you based on token. So it will charge you very heavy cost if you are passing these many tokens every time. If you are, there is a simple question and if you pass these many tokens, it will keep charging you. In order to save that cost, there is a framework called RAG, retrieval augmented generation, RAG. We will be using that, and in order to fetch the, or in order to store this data into the embedded format, we will be using Azure AI Search as a vector store. Now this vector store, you can use any vector store. You can use ChromaDB, you can use Pinecone, or you can use your local databases as well in order to store that. But as we are building the solutions in similar line with the organization, so organizations mostly use cloud-based databases, and as we are using all the Azure related services, let's go ahead and use the Azure vector search. And you can create the Azure vector search free, because once you have the active account, I think 2 or 3 indexes you can create freely. And for this project, we will just need one, so you can go ahead and create that. I'll show you how we can create that. So first of all, let's go ahead and create that Azure AI search. Okay, so go to your portal.azure.com and click on resource group. We have already created one resource group, if you remember, RG Intelligent Ticket. Inside that, let's click on create. Once you click on create, here you can search AI search. You can see Azure AI search. Earlier, the name of this particular service was Azure Cognitive Search. They have changed it to AI search. Let's select this particular resource. Hit on create. You can see this is the subscription that we'll be using. This is the resource group that we already created. Service name, let's give, as it is a Azure AI search, let's give name AIS hyphen intelligent ticket. And make sure that in the pricing tier, you click on change pricing tier and select free one. You can see 3 indexes. You can create maximum 25 MB vector data and total 50 MB vector storage you can store. And this is more than enough for us to try it out this particular POC. So let's select this so that it will not charge you. So click on review and create, and just click on create. So this will create this AIS service, Azure AI Search service. You can see the deployment has started. So let's wait for the deployment to get complete. Okay, you can see the deployment is successful. Let's click on go to resource. This is the AI's intelligent ticket AI service that we have created. Now, again, if you are new to this service, I would recommend go ahead and check out the playlist. We have covered this particular AI service as well. There is one more project that we have covered end to end, where we have used AIS service in order, we have used the vector store from Azure in order to build a text to SQL project. So if you search text to SQL project by iTech, iTech is our channel name, you will be able to easily get that, or go to my channel and you will easily find that particular project. And again, it is available in the same playlist. So let's click on keys. We will be needing these details. So first of all, let's grab the details that are required. So go to our environment file. And these are the details that are required. First of all, Azure search endpoint. So let's go ahead, key. So whatever key that we have copied, let me show you that again. You can copy this key, any primary or secondary key. And again, do not share your key with anyone because keys are very private to your environment. And if your key gets leaked, then there are chances that it will cost you heavy because anyone can use your key. So make sure you are not exposing your secrets. I'm exposing the secret here because I'll go ahead and delete the resources before uploading this particular video. So for easy understanding purpose, I'm showcasing everything. And in order to grab the endpoint, so if you can click on overview, and this is our endpoint URL. Let's copy this endpoint URL. Let's add it here. Now the endpoint is added, and the Azure OpenAI deployment. Now here we need to pass a model that we'll be using for creating the embedding. And in order to create the embedding, as we are using Azure Search, we'll be go ahead and using this text embedding 3 small model. But if you have any open source model available with you, which can do the embedding, you can use that model. The reason we are using this because Azure OpenAI embedding, or sorry, the OpenAI embedding works very good with the OpenAI models, and that's where we are sticking. For the agents, we are passing generative 4 model, and in order to create the embedding, we are using text embedding small. So let's go ahead and create this particular deployment. So under this particular Foundry service, if you go into models and endpoints again, you can see this GPT-4 we already created. Let's go ahead and create the text embedding model as well. So here you can search text. You can search embedding and you can see text embedding 3 small. This is the lighter model that is available. We no need to go for this 002 and large model. Let's select the small model, which is more than enough for us. And again, in the deployment, you can customize this. You can reduce the tokens to, let's say, 50K, which is more than enough for us. 55K. And you can see this resource it has created the another resource where exactly this service is currently available. So that's fine. We can go ahead and hit deploy. It should not take more than 4-5 seconds. You can see the model is created. Now you will see that endpoint will remain same. Just model name will be different. And your API version will also remain same. We no need to define that again and again. We just need to give model endpoint name. And you can see other details are exactly similar. Like the endpoint, the key, all those details will be similar because we are using Azure Foundry service. In Foundry service, you create n number of models. You need to, but their endpoint and the key will remain same, so that you no need to manage different keys and different endpoints based on different models that you are using. So if you are using 5 models from the Azure Foundry, you need to grab only one endpoint and one key and the 5 different models. So that's the benefit. Okay, so we have this handy with us now. Now we can go ahead and start writing a code in order to create the AIS service or vector store. I will show you a way with which we can create the AIS service. So if you go into search management inside your AIS, click on indexes. So you will see currently there will not be any index. You can create the index from here. Either you can upload a JSON file or you can create add index and you can manually create. Let's say we are adding this. Let's say creating a test index. You can see here you can create the fields that are required. So currently there is ID field. I can create, let's say, one more field, category. Here we'll be passing category, and you can see the fields idiom string. This is the data type that Azure uses in order to store the category metadata. So whatever category we are passing, its metadata will be stored into string. And here you can see configuration attribute. You can select whether can we retrieve this particular attribute, can we filter based on that, can we sort, can we use face table, can we make it searchable. And here you can select the searchable algorithm. There are multiple algorithms. These algorithm make sure that whenever you are searching the vector store, whenever you are matching your ticket description with the available vector store, then it is making sure that that matching is based on these algorithms. So these algorithms make sure that it converts it into a lowercase, all the description into lowercase, then it removes the stop word, it removes the extra spaces, so that it makes sure that you get a very good matching results. And exact matching, not exact matching, but very semantic meaning matching will be extracted. So that is the reason you can enable these fields, and then you can click on save. You can see this particular field is created. And once this mapping is created, let's say if I'm clicking on create, you can see the mapping is available, and here you can upload your document. Now instead of writing this or uploading the file manually, we'll be using a code in order to create this mapping, because in your ideal environment, right, whenever you are working in the organization, we don't follow this method of creating these services manually. Mostly we use our software development kit to create these services. And what's the benefit of doing that? Let's say today we are working in dev environment. So in dev, I have created this particular service. Let's say tomorrow I want to move my code to the upper environment, let's say like SIT or UAT, and then to the production. Now what will happen that I need to keep creating these services every time in all the environment. And whenever I'm creating the services, what if let's say some details I misplaced, like I have added some misconfiguration, name I have given some name I have given incorrectly. What will happen? Your code will fail into upper environment, and also it is not standard practice most of the time, right? We don't have these write and create option permissions available in our upper environment. So in production, your cloud team will not give you the permissions to create these resources. You need to manage those through your code, and for that they will enable a manage identity. So I would like to cover that manage identity in another video. Let's not go there. But the way we are creating these services, right? Like they will create one AD group for you, and for that AD group, they will grant access that you can create these keys through your code. And once you write that code, you just need to change the configuration based on your environment. Let's say today in your dev environment, let's say this is your URL. In your UAT, the service will be different. You need to go ahead and manually upload that file. You can grab these details and you can pass that into your environment config, and then with the help you will be able to create that. So we are also going to see the same way, but yeah, here you can manually add your records. That is completely fine. You can create the record in JSON file, and that also you can upload. And in JSON file, the file that I showed you, right, the data set, it accepts the format in that particular format. So and also let me show you what are the parameters that are required. So if you click on edit JSON, how exactly it creates that particular index. So you can see for each index it creates this metadata. For field ID, it is EDM string, meaning it is in the string format. And these details, it is filterable false, retrievable true, stored true, sortable false. Similarly for category, it has created these details. Similarly, we will be creating multiple these categories now. Like we will be having ID, we'll be having category, then we'll be having description, right? So let's go ahead and do that. So for that, let's go ahead and write the code. Okay, in order to write that particular code, we can create another file, create and upload index, and we'll be writing all our code into this particular file. So let me copy the complete code and I'll explain the code line by line. Again, it is simple code. Okay, first of all, let's go ahead and install the dependencies required to create the or use the Azure AI search. So we'll be requiring the Azure AI search in order to connect to the Azure AI search. TQDM is required in order to track the progress. Whenever we are uploading the document, it will show us the progress, how many document uploaded out of the complete document. And AutoGen core is required later on whenever we'll integrate a group chat functionality. But yeah, let's go ahead and install these dependencies. Pip install -r requirements.txt. This will make sure your dependencies are properly installed. And then you can see now, these are the details that we'll be using. You can see from azure.core.credential, we'll be using Azure credential. This is required in order to connect to your AIS service, Azure AI search service. Then again, from search documents, we'll be using search index client. These details are required in order to create your metadata into the format of that is required by the AIS. And then these details that we saw, like search index, search field, the vector search, sortable, all those, and the algorithm details, which is used in order to find out the similarity match. Then here we are importing these details like the OpenAI and the load.env. This is in order to embed our data. That's where we will be requiring this. And again, in the configuration, you can see search endpoint, the search endpoint that we have given in the environment file. This is the search endpoint. Then the Azure search key, that is what again we have given into the environment file, this Azure search key. And then this is the index name. We'll be creating the index with IT ticket solution index. This is going to be our index name. And then we'll be using OpenAI model that when we have deployed the text embedding small. So again, for that we need to pass OpenAPI key, endpoint, the OpenAPI deployment name, this name, OpenAPI, Azure OpenAPI deployment name, right? And the model version. Now, As we have already loaded this data into knowledge-base.json, so you can see in the data we have knowledge-base.json. This is our data file. We need to create the indexing based on this particular data. And vector dimension is required in order to make sure that you are creating the embedding within that limit. So each vector will have this particular dimension 1536. This dimension is required in order to create your index. So whenever you are creating embedding, you should define your embedding size so that it becomes easy for us to do the matching similarity. Let's say whenever you are creating the embedding, you have kept the dimension as 1536. Now whenever user is going to ask the question and you are going to match that question with user query, at that time you need to compare that user query with the embedding that is already available in the system. So while doing that comparison, the stored embedding should be of 1536 dimension, as well as the query coming from user that we are going to embed should also be in the same format of 1536, so that your matching becomes very easy. Like you will be able to accurately match your two results semantically, and then it will fetch the nearest match result. Now in the credential, we'll be building this particular credential. So this Azure credential class that we'll be using from this particular Azure identity. Here we have seen Azure identity or Azure credential. And then for that, we will be passing key, the search endpoint, and the credential, this credential, and that will create a search client. And this search client will make sure that it is going to connect to the AIS service. And then OpenAI client we have created in order to create the embedding. So this is going to connect to the OpenAPI or the text embedding small model. This is going to make sure that it is building a connection with the Azure AI search service. Now, now it's time to create the index. For creating the index, as I mentioned, we need to define these fields. So what are the fields that we'll be capturing? So in our knowledge JSON, we have these fields: ID, category, problem, and solution. So let's create those fields. First, ID, category, problem, solution. So search field, simple field is for ID, and search field for making sure that we can search these fields. So this is available inside the search field is available inside the azure.search.documents.index.models, right? And then for each, we need to define the type. Type is searchable field type dot string. Key uh, ID is going to be our key, because based on this ID, we'll be retrieving the details. I will tell you why exactly we will need this particular. Then filterable true, sortable true, face table true. These information we are passing to all these fields. Face table is nothing but it makes sure that it groups your similar category data into one particular. What basically we can say that it groups your similar content into one group, so that it becomes very easy whenever you are searching that particular record. So let's say your query is related to, for example, it is related to software category error. So it will store those software category error into one particular group, so that let's say whenever your classifier agent will classify that, okay, the category of this particular user issue is software, then it will make sure that it is searching only into the software group in order to find the nearest match. That way your retrieval becomes very fast. You'll be able to quickly retrieve your details. Also, this ID is going to help us in order to make the searchable very fast. Now, why we are creating or mentioning it as index? Because index is a terminology used in vector store in order to make sure that it retrieves the information very fastly. Because with our normal databases, if you start finding out the exact matches, right, then it does the character by character matching, and it takes a lot of time to fetch the matching results. But that is not the case here. Here we have already converted our text into the embedding in the form of vector. Now, whatever you have is the semantic vector. Now, you just need to match, you need to find the cosine similarity between two vector. One vector that is available inside your vector store, one vector that is coming from user. You will match, find the cosine similarity, and you will pick the maximum one which is having the highest closest similarity. And whenever you have that record based on this index, it makes easy to retrieve that particular information. And that is the reason we use index. And then we are creating this search field where you can see we are embedding these particular details. Embedding meaning, again, it will create the vector embedding. It will create the semantic similarity. I hope you are aware about how exactly the natural language query or text is converted into embedding. So there are embedding models that are available. The one we are using is the text embedding small, which converts this particular text into semantic meaning vector. That is what it will do. And then we are passing the collection details and the vector dimension, right? And making the search profile default. Now with this, we have built those fields. So whatever fields that are required, these fields, we have built these fields now. Correct. Now here we can go ahead and write the algorithm that we need to use in order to fetch those details. So you can see in vector search, we are using HNS algorithm configuration. Now this HNS algorithm, what exactly it is, it will make sure that it uses a nearest neighbor functionality in order to find the similar matches. So whatever vectors that we are using, based on this particular algorithm, it will find out the closest match with the help of nearest neighbor. That is the functionality. That's where we have given algorithm. There are multiple other algorithms which some of them uses, let's say cosine similarity, k nearest neighbor they uses. Likewise, different similarity search or clustering algorithm it uses in order to find the similar queries. And then profile, we are using this particular algorithm configuration default. There are different algorithms that are available. Let me show you those algorithms. If you go to the index and if you click on create field, here you can see the searchable and you can see analyzer. These are the algorithm. These algorithm make sure that, as I mentioned earlier, make sure that whatever queries and information that you are passing, it converts that into lowercase so that there will not be any conflicts while doing the vector similarity match. So everything will be converted into lowercase. It will be tokenized, uh, meaning all your words will be chunked into small token, and then it will be converted into vector form. So that's the reason the algorithm is required, and that is where we have used the default algorithm. And then here you can see we are searching, that we are creating this particular index object, and then we have written this particular function. If this particular search index that we have given, the search index name, IT ticket resolution index, if it is available, sorry, in the try, if it exits, then we are skipping the creation loop. So in the try, if we get that particular name, then we are returning already exists and skipping the creation. If it is not there, then you can see we are going ahead and using the create index function that is available in the client, and we are passing this particular index and we are creating that index successfully, right? So till this part we are creating the index. So let me show you now how exactly it looks like. So we can write a main function in order to test that. Okay, so I'm writing this particular if condition where we will be testing this particular create index and we'll test whether it is working or not. So this create index will see whether it is creating this index, because currently it is not available. So let's go ahead and run this Python create and upload index.py. Hopefully there should not be any issues. You can see it is creating the index and then it is saying index has been successfully created. So let's go ahead and check out that. So in the indexes, okay, you can see IT ticket resolution index is created, and let me show you the schema. If you click on edit JSON, okay, you can see we have ID field, then we have category field, we have problem field, we have solution, and the embedding that we have created. And then you can see other details that are required. You can see the dimension is 1536 for the vector. So this is the vector store that we have created, this particular index. Now we need to upload the document. You can see there is no data available. So let's go ahead and write the upload code. Okay. Again, upload code is going to be very easy. So first we are creating a embed text. Whatever data that we have, we need to embed that. And for embedding, you can see we are using OpenAI client dot embeddings. We are creating this particular embedding, and in that we need to pass the input text. So whatever text we will pass to this particular embed text function, it will embed that and will be using Azure OpenAI deployment. This is the model that we'll be using. Text embedding text, this particular model, not this model. Actually, it is small model. So that model will be using. And then let's load the data. Now we know that data is available in data file, that is this particular knowledge base. So if you see data, under data we have knowledge base.json. And then once we load that particular data, we are loading that JSONic object. And then we have written a upload document function in order to load that. So first of all, we need to create the documents. So these documents is nothing but, let's say, So whatever data information that we have, first of all, we need to create document out of that. So document is nothing but collection of tokens. So each query that we have inside our JSON object, we will create individual document, and those documents we will push. So you can see for the document, we have batch size of 100. And for those 100, we are using TQDM. This is the TQDM is in order to show the progress bar. I'll show you whenever we are executing that code, it will show the progress bar, how many documents that we have uploaded. Then from the search client, we are uploading the document. The simple code is just to iterate through that batch size, and it will make sure that we are uploading the document in chunks, because again, you can upload multiple documents at a time. That's where 1,000 documents we are uploading. In our case, it is less than 1,000, so that is fine. We can reduce the batch size to 10. We can load 10 documents at a time. And let's write a main function. So this is the main function. First of all, we'll create the index, whatever we have given here. First, we'll check whether index is available or not. If not, we'll create that. Then you can see we are loading the data. This load data we are calling in order to load that data. And then enrich documents will be creating the list of documents. And here, if you can see, we are iterating through that particular raw documents that are available. This raw document meaning the file that we have loaded, JSONic file. From there, in the embedding, we are passing the embedding, right? Because we are creating the embedding. So if you can see here, embed text is the code that we have written or function that we have written in order to generate the embedding. We need to add the embedding against the document. So for this particular document, we have added the embedding, and then we have added that embedding into this enriched documents. So in this one, we have now this particular format available. This is the format, embedding, and these information with the vector store. This embedding we have already stored now. So that embedding is available in document, and then we will go ahead and upload that particular document. Okay, now let's go ahead and call that main function here. And first of all, let me go ahead and delete the created service, or you can keep it anyway. Now it will skip that particular loop because we have already created that. Now let's go ahead and run this particular file again. Now you can see one progress bar here. You can see creating index, and then you can see the bar. This is the TQDM library that we have used in order to show the progress bar. You can see document uploading. And as we have given the batch size of 10, in the first batch, 10 documents uploaded, and in the remaining, we have uploaded the remaining documents. So that's how it has uploaded all the documents in 2 batches. Now, let's go ahead and check out that whether the documents are available. Sometimes it takes time to load that information into this particular index. So we need to refresh it sometime and then, or wait for some time, and you will be able to see that documents available here. Okay, as it is not loaded, but what we can do is we can go ahead and check out whether that metadata is available or not. So let's go ahead and search for this particular. How can I change my password proactively? Now, if it is uploaded, it should be available into that. So in the search, this is how whatever user query will be there, we will be embedding that and doing the search. But here, if you are passing this, it will go ahead and do the search. So you can see it is searching, and you can see the match record with this core is available. How can I change my password proactively? Log into company portal and go to account setting and click OK. Log into account portal, go to setting and click OK. And this is the change password. That is what it has extracted the record. Meaning, and you can see it has extracted the top match record. Meaning the data is already pushed to our vector store. It is not showing the document here because sometimes it takes time. Okay, you can see now the data is populated. 17 documents we have uploaded, and you can see how much total storage it has consumed and the vectors index and the maximum storage that is available. So this data is available. We have pushed our data into vector store. Now it's time to test whether this search functionality is working or not. For that, we need to write a search code as well, which will hit to this particular service and extract the matching records. So for that purpose, now first of all, we need to write second agent, knowledge base agent. As we have mentioned here, this part is done. Create and upload index is done. This is one time activity. Now this is done. Now as classifier agent is done, let's go ahead and start writing knowledge base agent. And in the base agent, we will write these particular details. Now we'll embed, we'll do the vector search, and we'll extract the top n records by writing the search index tool. And for that, we will be enabling tool functionality for the agent, and also we'll understand how we can integrate or how we can register the tools for the AutoGen agent. So again, it is going to be very simple. Let's go ahead and check out that. Okay, now we can start writing our knowledge base agent. So inside agents, let's go ahead and create new file, knowledge base agent.py. Okay, so let's start writing our knowledge base agent here. So again, from AutoGen, let's import the assistant agent because we'll be building assistant agent. And then let's write a function, hit knowledge base agent. And inside that, let's use the assistant agent class to create the knowledge base. So the knowledge base agent. So assistant agent we are using, name we are giving knowledge base agent. System prompt, you can see you are an IT support assistant that retrieves solutions to the user issue. Always call the search similar solution tool with the query to get the matching solution. After calling summarize the top solutions and respond with terminate. This terminate in order to terminate the conversation. So we are requesting this particular tool to call the search similar solution. This is going to be our tool with the query in order to find out the get matching solution. So after this, let's go ahead and give the LLM configuration. And this LLM configuration, again, we can import it from the utility. So from utility dot LLM configuration import LLM config. Let's pass that LLM configuration and then pass the code execution config as false because we are not going to execute any code. So we need to define that as well. Okay, so our knowledge base agent is ready. We have given these details, configuration and code execution. Now we need to register the tool because for knowledge base agent, we are calling tool. If you see in our diagram, this knowledge base has a tool capability, this particular tool, we need to pass this particular tool and then it will be able to hit to the Azure AI search that we have created. So we need to write that custom Python function. So it is going to be the Python function and we can register that Python function as a tool. And registering the tool in AutoGen is very straightforward. So let me show you that. Okay, you can see we can register the tool with LLM executor. So knowledge agent that we have dot register for LLM. This is the function that is available inside knowledge agent. And we just need to give the name of the tool, search similar solution. This is the search similar solution as we discussed. And description, searches for top IT solutions from the knowledge base using vector similarity search, accepts query and top K. And then the function we need to pass the Python function. As this Python function is not written, let's go ahead and write this particular function. So we can go ahead and write that function into tools because that is going to be our tool. So as we have not created any tool, let's create a folder called tools, and inside tools, let's create the file knowledge base tool.py. Here we'll be writing that particular Python function. So first of all, let's import the necessary dependency. Again, Azure OpenAI is required in order to convert our natural language query into the embedding, and then load env in order to load the secret, right? Okay. Now let's load the secret that are required, the configuration. These are the configurations that are required. Azure search endpoint, the Azure search key, then the IT ticket resolution index, this is the ticket name, the OpenAPI key, OpenAPI endpoint, the OpenAPI deployment, and the OpenAPI version. Now, you might be thinking why these many details are required, because this search related information is required to connect to the Azure OpenAI, connect to the Azure AI search, and the OpenAPI related configurations are required to connect to the OpenAPI service in order to use the text embedding model, right? That is where all the configurations we have already defined into our secrets. All the secrets we have already defined into our environment file. Okay, let's continue. Let's build the connection client. So with the help of this client, we can connect to our OpenAPI service in order to use the this particular model, OpenAPI model deployment, that is text small model. Let's write the code for embedding. And we have already written this particular code. So if you remember, inside this agent base, we have already written this particular tool. Sorry, not in the base. In the create and upload, if you can see, we have written this particular code in order to generate the embedding. Similar code will be using here in the tools embed text, which can generate the embedding of the text that we are passing, that the user question. Now let's write a function in order to hit to the Azure AI search and extract the top match records. So this is the search similar solution, which will take input as query, the user query and the category. So if you remember, our this particular agent, classifier agent, is generating this particular format, ticket and category. So we are passing one, this ticket meaning the query of user, mouse is not working, let's say, and category hardware issue, that is the category that we are passing. And then we are generating the embedding. So with the help of embed query, we are passing that query and generating the embedding. Then we are building connection to Azure search. And then we are passing this particular header in order to connect to that Azure AI search with the help of search key. And this is the payload that will be passing. So first is the search, which is null. In vector, we are passing embedding and top three matching records. And here you can see select category problem solutions. Out of that particular metadata that we are selecting category, problem and solution. This, if you remember, we have already created these many fields onto our AI search, and then we are filtering based on category. So whatever category that we are passing here, this category, it will make sure that the top match records, out of those top record match records, we are filtering out the category that is relevant. Only those top match records we are utilizing, right? And then in the response, we are connecting, sending and post request in order to send this information back to our AI search and do the similarity search matching. And then you can see we are getting the result once we hit to that, and then if there is no result, then we'll print that, return that. And if whatever results we are getting, out of that results, we are enumerating that, meaning we are iterating, and we are generating the response text. And in the response text, you can see we are finding out the ID, we are finding out the category, problem and solution, and we are creating this response in this response text format, and we are returning that. I'll show you how exactly it will look. So from that particular document that we'll be getting in the result, first of all, we'll get the category of that particular problem statement, then we'll get a problem and with the solution, so that we can show that solution to the user. Because whenever we are showing the solution to the user on user interface, at that time we'll be showcasing what is the solution for that particular problem. Let's go ahead and test this particular function. So we can write underscore underscore name equals to underscore underscore main. And in order to test this, we can write this particular simple query that, okay, my Outlook crashes every time I open it. And we are getting the RAG output because this is the RAG tool that we have built. We are calling this search similar solution, this particular function. And in that function, we are passing a query and the category. So currently, let's hard code this particular category in order to test whether this AI search is working or not. Because whenever with the help of group chat functionality, we are connecting these multi-agents together. At that time, this classifier agent will automatically pass this response to the knowledge base agent. But for now, in order to test whether this tool is working or not, let's pass this category and the query, and let's put the RAG output, print the RAG output. So let me clear the screen and let's write Python. As this is available under tools, we need to go inside tools first. In tools, Python knowledge base tool.py. Now for this particular query, it should identify the top matching records. So you can see it is hitting to that particular vector search. The connection was successful. Category software bug, a problem Outlook crashes on opening, and this is the solution that it has given. And second top match record is Teams not syncing messages, which is not relevant. And as you can see, we have filtered the bug with, filtered the category, that is software category. So it has only it is only showing the software related bug. Third query it has filtered out. That way it is making sure that it is filtering the irrelevant record and only passing the correct record to the next model, next agent, that is our passing these records to the agent, that is our knowledge base agent. Because this is the tool output, now we are feeding to the knowledge base agent, and knowledge base agent based on this will respond what is the final output, right? So this particular thing is working. We are able to connect to our knowledge base, that vector store that we have created, and we are able to hit this particular query. Now let's pass this particular search tool into our agent. So inside agent, we have this knowledge base agent. So here you can see we have passed that particular tool. Let's import that particular tool from tools dot knowledge base tool, import search similar solution, and that search similar solution we can pass here, right? So we are all set now. We have created knowledge base agent, and we have given this feasibility for knowledge base agent to register. We have registered this particular tool so that it can hit to that particular whatever Python function that we have written. See, we have only written the Python function, and that Python function we are registering to the agent as a tool's capability. We don't need to manage anything now because AutoGen has this feasibility to register these tools, and after registering, it makes sure that it is calling the tool as and when required, right? So let's go ahead into our test agent and write that our second agent so that we can test whether these two functionalities are working properly or not. Okay, so in order to test the second one, let's go into test agent test.py and let's write this particular second. So second, for testing the second agent, we have written this particular function run kb test, run knowledge base test. Again, we are creating a user agent. Now user agent will pass manually the input because currently we are not passing the output from classifier agent. At the end, we'll pass the output from classifier agent. But for testing purpose, let's see. Then you can see this is how we can register the tool. You can register it here or you can register directly in that file. So both is fine. And then we can start the chat. And in the chat, you can see we have given the issue, use the tool search similar solution to find the fix for my Outlook crashes every time I open it. And max turns 2 so that you can end the conversation. So let's import these two details first. So from tools dot knowledge base, import search solution, and from agents, sorry, from agent dot knowledge base agent, we need to import the get knowledge base agent. So that is what we have imported, and we are good to test this now. So instead of run test, now let's pass this run kb test and let's see whether it is working or not. So let's go ahead and run Python. Okay, we are in tools. Let's go one step back, cd double dot, and then Python agent test.py. Now, based on this particular category, it should go ahead and start the conversation. What's the problem? Agent test.py. Oh, sorry, we haven't called this particular tool. Sorry, really sorry. Now the conversation will happen between user and knowledge base. Earlier, we have tested the connection between user and classifier agent. So let's say our classification is done now. So let's see how exactly it will work. Okay, there is some problem. I think we are not returning that in the knowledge base. Yeah, we have missed. Sorry, my bad. Here we need to return this knowledge agent, right? So I forgot to add that. So let's go ahead and test this agent test now. Python agent test.py. You can see use the tool search similarity. So you can see it has given this particular detail user agent to knowledge base agent. Okay, you can see use the tool search similar solution to find the fix. My Outlook is not working. So this is the query and this is the software category. And this particular, you can see it is calling the search similar solution tool. Now that search similar solution tool, you can see I couldn't find the direct solution for the issue. Outlook crashes. However, okay, there's some issue. It is not able to call the tool. So let's see. Let's check out that. Okay, so I found the issue. So in this user initiate chat, we were not passing the category. So it was picking some random category. As we have not given the classifier agent, it was not passing the correct category. So here the category software work, we need to pass this and let's go ahead and execute the function. So agent test.py. Now this user chat itself is user chat agent itself is passing. You can see these details. The Outlook crashes every time and category software bug, and then it hit to the tool, and in the from tool you can see from the knowledge base tool it has extracted these two top match record, meaning this is working. Now we need to connect these two agents one after the another, and in order to connect the agent, there is functionality available in AutoGen called as group chat. So with the help of group chat functionality, we can connect these agents, and then we can facilitate the conversation between these agents. So we no need to pass this user agent again and again. We can just we can start the conversation with user agent, and then we can define the different agents that we need to get involved into the task execution. And the agents are smart enough that they can take decision which agent should go first, second, and then they can decide how to accomplish a task. So let's go ahead and start building that particular code. And one thing I forgot to mention, that in the knowledge base agent, there are two things. First, we need to register the tool. You can see we have registered the tool, and second, we need to register the tool for execution. So this is for registering for LLM, so that LLM knows which tools to call. That is this, and that's where we have given the description. And this is for the knowledge agent to add the execution capability. So here we are requesting agent that you can execute this particular tool, and that is where we have given the name of the tool and the function, right? So that was one thing that was missing. Okay, now as everything is working, let me close these. There are too many tabs, so let's go ahead and close those. Okay, so here let's go ahead and create group chat, group chat.py. Okay, let's go ahead and import these dependencies in group chat. So first of all, we'll be importing AutoGen from group chat and group chat manager and user proxy. So group chat user proxy agent we are going to use to create a user proxy agent, and group chat, again with the help of group chat, we'll be able to mention what are the group agents that we'll be using, and group chat manager is going to our another agent which will facilitate the conversation between multiple agents. In this particular diagram, as we can see, we have 3 agents, but there will be one more agent which is going to be the manager of these agents, who can decide whom to call at what point of time, right? And that is going to be taken care with the help of group chat manager, and that is very what we can say intelligent way of handling the user conversation or handling the agent conversation, and that feasibility is available in AutoGen. We call it as group chat functionality, which helps us, or which facilitate the agent conversation, which derives what input we should pass from one agent to another agent, what are the output format that is required in order to facilitate that particular conversation. So that is where we'll be using this group chat functionality. And from agent.classifier, we'll be using classifier agent, the classifier agent that we have written. Second, we'll be using get the knowledge base agent. So this is the knowledge base agent that we have written. So pretty simple. Again, we'll be importing the LLM configuration. Sorry. So from utility LLM config, we need to import the LLM config that is required in order to pass to the group chat functionality. Let's create these agents, whatever we have called. So first one is the classifier and KB agent. So we have created instances of these particular agents. Now here we can start a separate user proxy agent. And this user proxy agent, again, the way we have written this in the agent test.py, similarly, we can call this particular user agent. But now here we'll be adding a group chat functionality. So we need to define all the agents here. So agent test.py just we have written in order to test our application, but we are not going to use that anywhere, right? Then is termination flag message, we need to define the logic for is termination flag, and that logic is also very simple. So if you can see is termination message, we are passing the message, and in that message, if there is terminate word available, then we are going to end the termination. Again, this is very wise way of ending the termination in AutoGen. And again, we have covered this in depth in our playlist. So if you have missed that, please go ahead and check out that. Link is again available in the description below. So you can pass this you can use this termination flag method in order to dynamically terminate your conversation as soon as your conversation is end, or as soon as you get the response, you should terminate the conversation. So this helps us in saving the cost, because let's say if you have 2-3 agents available, and if you are not terminating the conversation, the agentic in agentic AI, right, the conversation goes on continuously from one agent to another agent until it is hitting the maximum the occurrences that we have given, maximum turns that we have given, and that is unnecessarily wasting your tokens, and that is charging you, right? In order to save that, once you receive the final response, let's terminate. So that is what we are doing here, and that we have given the functionality for user, because user is the user proxy agent, meaning who is going to act as a proxy of user. So as we are going to automate this complete project, right? There should be one agent who can act on behalf of user. Whenever there is execution task, go ahead and execute that Python code that user proxy will do. Then currently we have given code execution as false because we don't have any code as such in that we want to execute, but because we are giving that functionality to other agents like knowledge base agent, right? Then is termination flag, it is deciding when to terminate or not. Then let's add the group chat now. So you can see we have used group chat class, which is available in the AutoGen, and then we can define the agents. Now in the agents, you can see we have defined the agents in list. First one, user agent, classifier agent, KB agent, meaning this group chat can collate all our agents that we are going to use or those are going to participate in the task execution. So those agents we have collaborated here. Messages, we are starting a empty list because this is going to store all the conversation history. All the conversation that is happening between these agents will be stored inside these messages. Then we have speaker selection method, automatic. Automatically, it will select which speaker we should select. First, it will select classifier, then user, KB agent. It depends, right? Then we are allowing speaker execution, allow repeat speaker false, because we just want to call one agent at one time, and that's it. Max round we have given 6. In case it is not able to understand when to terminate, it is not passing the termination flag, then we are, from our safety side, we are terminating the conversation after 6 round, right? Now it's time to write a group chat manager which will facilitate the conversation, which will start that. So you can see in the group chat we are calling this group chat class, and in the group chat we are giving this particular group chat LLM configuration we have given, and each termination message that is also we have given, so that manager can take that call. Now this manager will manage the conversation, when to call the user agent, when to call classifier agent, when to call knowledge base agent. Everything will be decided by the manager agent. Now let's go ahead and test it. Now as we have written everything, let's write this particular function, write this particular code in order to test this. So with user, we are starting this recipient is manager. User will pass the first message to, because conversation will always start from user. User will ask manager, okay, this is the task that I need to perform. You decide which agent to call and whatever you want to do it, but I want the final response. So manager will say that, okay, I have access to these many agents, classifier, knowledge base, so I can go ahead and use those agents. So first I will do the classification, then I'll do the knowledge base, right? So our issue is, first, please resolve this issue. Outlook crashes every time I open it. So let's see whether this multi class or multi-agent functionality is working or not. So Python groupchat.py. Let's see. If we face any issue, we'll be able to resolve that. Not an issue. Okay, you can see now how the conversation has started. So first you can see to chat manager we have given please resolve the issue. Outlook crashes every time I open it. It has called the next speaker as classifier agent. And then classifier agent to chat manager is saying that, okay, this is the ticket, please resolve the issue. Outlook crashes belongs to software category, software bug category. Classifier agent task is done. Now classifier agent will pass that output to the chat manager, and now chat manager is selecting next speaker as knowledge base, because chat manager knows now once we have the category and ticket information, I can call a knowledge base agent. So you can see it has called the knowledge base agent, and knowledge base agent has returned to the chat manager, hey, whatever you have given to me, based on that I need to call this particular tool, search similar solution. As I need to call this particular tool, you can see it is calling next agent as again speaker, and then it is doing the execution. You can see executing function search similar solution. How wisely it is doing these all these things, right? And it has extracted these detail. Now this is the output written by the tool, correct? And based on that output, it has given to the knowledge base, and knowledge base is then now know that this is the output. It is saying to the chat manager, hey, I have done the execution, get this output. This is the output that I have generated for you. See whether it is making sense or not. So this is what it has given in this particular format: result 1, result 2, these two top match results, because it hit to the Azure AI search, extracted those details, and now these details it is handing over to the chat manager, and then chat manager is calling next user as next speaker as user, and then you can see we are passing the terminate. So to resolve this particular issue, final response is this: we need to run this particular command outlook.exe /. safe, and then it is ending the termination. Once they're terminated, we have received the final output. Meaning in the group chat functionality, now you can see how exactly the communications are happening between different agents in sequence. The automatic way that we have given is automatically selecting the agents. So that is the beautiful way of AutoGen, because it has this capability where it can communicate with multiple agents. If you want to see more examples, then go ahead and check out the playlist, because I have covered few other examples as well in the playlist. Yeah. Now our group chat is also ready. Now we need to build our third part, that is notification agent. And that notification agent is going to send out an email. And for that also we need to write another tool. I know this video is very lengthy, but I would highly recommend please stay back and keep watching this particular, because this is the real-time project, and building real-time project always takes time. So be patient and keep watching. Okay, so to create the notification agent, let's go into agents and create one more file. Let's give the name as notificationagent.py. And let's create a simple agent. So again, so let me import from utility.llm configuration, import llm config, and then get notification is the function that we are writing. And again, name we are calling assistant agent from AutoGen, and name is notification agent. And what is the task? You are an IT notification agent that sends alerts or escalate and resolve tickets. So whenever on the UI we saw, whenever user is clicking on issue is not resolved, then we are calling the next agent, that is notification agent. Now this notification agent will intelligently create a ticket and send out that ticket to the support team. So for that we need to enable the tool execution functionality here, that we can define in the app.py, the final file that we will be building. Now this is the agent, and let's write a tool that we will be using in order to send a notification. In the tools, let's create send email.py is the tool. And for that we'll be using SMTP library. Now SMTP is the simple mail transfer protocol library which is available in Python, which helps us connect to our email account and trigger those emails. Now you can see we are using these particular details like mi, met, ext and mi multi-part. This is required whenever we are connecting to the Azure, whenever we are connecting to the email account. And for that, we'll be using these credentials. So I'll be using my personal email. So SMTP server, as we are using gmail.com. So this is the constant Gmail SMTP server for all Gmail account, smtp.gmail.com. Standard port, you can give 587. This is my email ID. I'm going to connect to this particular email ID. And from this email ID, the mail will go. And then sender password, I have created this particular password. We need to use a app password for Gmail. This is not my email ID password, right? This is the password that we need to create. And in order to create that password, first of all, we need to go to this particular site. Let me show you. myaccounts.google.com/apps password. And in that you can log in, and then it will give you the feasibility to create the password. So here you can create password. You can add your name, and then you can create the password. So this is the IT notification password that I have created. So let me close this. You can create that password, copy that password, and pass that password here. So I'll be deleting that whatever password I have created before uploading the video. So again, please do not share your secret, right? Now next part is the function to send an email. So this is the send email function, which will take email for which we want to send the email, the subject and body of the email. And here you can see we are using this library in order to convert that email body into this particular format wherever this SMTP library is required. So you can see message, and in that message from we are passing sender email, to we are passing to email, that is what we are getting from here. Subject, we are passing the subject that we are passing, and then we are attaching if there are any attachment. The body we are attaching currently, and with SMTP lib we are connecting to the SMTP server and port. So to this account we are connecting, and then we are sending the email. So with the help of send, you can see we are logging in first, and then we are sending this particular mail. to this particular email ID. And if there are any errors, we are returning that. Now let's see how we can pass or how we can create these details, email ID, subject, what are those details, right? So for that, let's again write one more function in a very simple function. You can see escalate ticket with email. We need to just pass the issue, whatever issue we are getting from user. Let's say whenever user click on issue is not resolved, whenever user will click on that, it will collect this issue. And then subject, we are giving escalation and resolve IT issues. Body is this particular body. We are passing the issue here, and please investigate and take further action. And this is the action. The final regards we are adding, and then we are sending that email to this particular email ID. So for now, I'm using same email ID to send to the same email, right? But you can change it later on. Like you can add any other email, whoever you want to send. Here you can add your support team email ID, right? And subject, it is creating body. We are passing whatever body that we have written. Sorry, to this particular body, and the subject it will pass. And then it is returning the output in this particular format, content, and this particular content, email sent to IT support if success or else fail to send. So this is what it is going to return. So now our email tool is also ready, send email tool. With the help of this tool, we'll be able to send the emails. Now our knowledge base is also ready. This particular email is also ready. Now what we can do is we can go ahead and enable this particular knowledge base into our group chat. So go inside group chat. Here let's import another agent. So let's import our notification agent, and this notification agent, let's import it from agents dot notification agent, import get notification agent. So now we have all the three agents available here. And in order to bind the tool functionality, we just need to write this, bind this manually to the agent. So notification agent dot generate reply, we are binding this particular tool. So this is another way of registering the tool to the notification agent. So escalate ticket with email, let's import that as well. So from tools dot send email tool, import escalate ticket with email. So that detail also we have imported. So as our all the agents are done, we can go ahead and we have written all the agents. Now our notification agent is also ready, our knowledge base agent is also ready, our classifier agent is also ready. Let's go ahead and integrate all these agents into app.py, where we will be writing some user interface related details as well with the help of Streamlit library. Okay, so let's go ahead and create app.py. Now this is going to be the Streamlit code that we are writing in order to build the user interface. And again, the focus is not how we can build a decorative user interface. So I will not go into the depth of whatever UI code that we have written. We will mostly focus on how we have integrated these all functions together in order to make it work. So first of all, we need to go ahead and create the style.css. So this style.css will help us in order to write the beautification for our website. So style.css is there. Let me go ahead and paste that code. So again, this code is just to make sure that whatever UI that we are building, to add color coding to that, add background, the border details, the text box that we are writing, what should be the color of that particular text box, those containers, all those details we have given here. And again, it is a UI related thing, so I don't want to get into that. But if you want me to cover this, so I can cover the Streamlit related part into any new video. So if you are interested, ping me down. I'll cover the Streamlit part into another video. Now into the app.py, let's start writing the code. Okay. So first of all, let's go ahead and install the Streamlit. So here let's add Streamlit, and let's go ahead and install that pip install -r requirements.txt. So while it is installing the dependencies, let's go into app.py and let's start. So you can see we are importing Streamlit as ST. Then from group chat, we are importing user, manager, and notification agent. Now this notification agent, I have already added it into the group chat.py. Let me show you. As we discussed, you can see notification agent we have added, and we have bind this particular tool to that. So that is there. Now we have the function to create the ticket ID. So whenever user is clicking on the issue is not resolved, it is going into this particular generate ticket ID and creating a ticket. So ticket prefix with ticket, and after that we are creating a 6 length of ticket. So you can see random ticket we are creating here, a simple code that is written. Now this is where our UI will start. So we are loading the custom CSS, the style.css that we have written in order to beautify our website. So that is what we are loading, and then we are starting the, we have set the page configuration. We are giving the title to the page as SupportX AI Assistant. This is the name that we have given for our bot or for our tool. And then we are giving the title, these markdowns we are creating. This is the title that we are giving. Then the subtitle we are saying your personalized AI IT support assistant, all those details, right? That is what we have added. Then coming back, again, these information is in order to start the setup. We are starting whether final response is obtained or not, the user input, awaiting feedback. Those details we are starting. Again, it is required for the Streamlit to start the conversation and maintain the conversation. So again, you can see here we have input. We are passing this particular input. Then we have this particular logic. Whenever we are submitting the button resolve now, whenever user is clicking on resolve now, first of all, it will go ahead and start the conversation. So you can see it is starting the user initiate chat. Whenever we are starting the user initiate chat, you can see we are passing manager and the user input, whatever input that user has given. And with that manager, it is starting the conversation, and then that manager will start looking into the different agents who can perform which task, and it can hand over those communications. And then it is generating a final response. That final response will be visible to the user interface. So in between, it will give a call to the knowledge base agent. It will hit to the AI search vector store. From there, it will extract the top match records, and it will generate the final response and hand over that final response to the user interface, right? And then for user feedback, there will be two options. First button, yes, issue is resolved. Second button, no, issue is not resolved and not useful. Whenever user is clicking on the button, no, not helpful, then you can see we are creating the ticket. So whatever ticket code that we have written, it will create a ticket, which will get us the ticket ID. And then we will start. We are escalating this issue with IT support team, and this particular ticket created, and then we are calling the notification agent. Now, this is the point where we are calling notification agent dot generate reply. Now, in this point, our notification agent will give a call to the email tool. It will pass these details. It will send out an email to the support team, IT support team. And that's where it will generate the final response and showcase that, okay, notification agent response, final response, meaning the notification has been sent to the IT support team. So this is the simple code that we have written. We have just collated all those scenarios or all those agents into this. And again, we have used this group chat functionality itself. Everything is defined in the group chat, right? Now, it's time to check whether our code is working or not. I hope it should work. We have installed all the dependencies. But if you are still watching this particular video, I really appreciate your effort. It is difficult to stay till this long and continuing the coding lecture. So it is tremendous. So I really appreciate your effort. So let's go ahead and execute this particular part, because this is the last part that is pending. We will execute and try it out the UI, whether it is working or not. And that's that's the most interesting part. So in order to run the app.py, we need to use Streamlit command. So the command to run the Streamlit is Streamlit run app.py. Now Streamlit is a library which help us build the user interfaces quickly. So you can see why we have just written 104 line of code, and we have integrated all the agents. Also, we have written the user interface code as well. We have written all the styling information in style.css. That's where the code is not that long, but still it is not that lengthy code, because UI codes are ideally very lengthy, right? If you are having experience with any of your framework like React, then you might be knowing that. So let's go ahead and execute this Streamlit run app.py. Hopefully it should work. Fingers crossed. Okay, you can see it has opened our user interface. Let me see if there are any errors. Okay, I don't think so there are any errors. So here we can describe our issue. Let's start and describe. So congratulations, like we are able to load the user interface. Currently we have not faced any issue. Let's see if we are facing any issue, we'll be able to definitely fix that. So my VPN is not working since morning, right? Let's see. Let's click on resolve now. Hopefully it should work. So you can see now the conversation might have started between the different agents, and based on that it will retrieve the necessary information. Okay, so you can see some error, the one missing attribute, positional argument, message. That's fine, we'll fix that. So initiate chat, messenger, okay, one attribute is missing. Let's go ahead and fix that. Okay, there was small mistake in the group chat. So in the messages, there was one issue. So we have fixed that in the messages. Now let's go ahead, because by mistake I added notifier agent into that, and that's where it was creating confuse, because we want to call the notifier agent once we are done with the first route. So this particular first route, once we are done with this knowledge base, if knowledge base is saying that, okay, this is the particular issue that you can try, and if that function is not working, then only we are calling the notification agent. But I called that notification agent before, and that's where it was causing the issue. So we have removed that now. Now let's go ahead and sorry, try it out. Streamlit run app.py. Okay, you can see we have loaded this. Let's type the question. My VPN is not working since this morning. Let's resolve now. Now it will start the conversation between different agents, and then first it will call to the classifier agent. It will extract the category and the description. Then it will pass it to the knowledge agent. Knowledge agent will hit to the AI search and get the response. Okay, fantastic. You can see it is working. So we have received the response. So to resolve this issue with VPN not working, please follow this step. Ensure your VPN client is up to date. Restart your PC, launch the VPN application, and try reconnecting. So user can try it out these methods, and user can say that, okay, yes, my issue is resolved. Once the issue is resolved, great. We are glad your issue is resolved. Everything is working perfectly fine. Now the first part is done, where we have tested two agents, classifier agent and the knowledge base agent. So this part is done. After knowledge base agent, we have given the feedback. This multi-agent feedback is given to the AI resolution. That is our UI. Now let's test this part. What if it is not used? What if this solution is not fixing the user issue? How can we then fix it? Let's say my laptop is not working. I can see a black screen all the time. Let's see. Hit on resolve now. So again, the conversation will start, and you can see I have made mistake in typing the laptop. Still, it will work because we have used the LLM model, and those are smart enough. You can see to resolve your issue with a laptop displaying a black screen, check the power cable, check the HDMI or display port connection, try connecting to another monitor if possible. No, this is not helping my issue because I'm using laptop and I'm not able to, my laptop screen itself is not working. So user will say, okay, no, not helpful. As soon as user clicked on that, you can see we are escalating this issue to IT support, and you can see it has created the ticket, and then it has sent the notification to the notification agent and email sent to the IT support. Let's go ahead and check whether we have received the email or not. So let's go ahead and refresh this. Okay, you can see we have received the response 0 minutes ago. Hello IT support team, the following issue reported by the user could not be resolved. Unresolved IT issue. This is the ticket ID. Please investigate and take further action. Well done. Well done. So it's working perfectly fine, right? And I will show you the conversation that has happened. So let me show you that. Okay, you can see my laptop is not working. I can see black screen all the time. That is what we have given. Then it called the classifier agent. Classifier agent identify the ticket and the category hardware issue that it has given to the knowledge base. Knowledge base has mentioned that I need to call this particular tool, search similar solution. It is calling the search similar tool, and this is the response that it is getting. And that response it is handing over to the chat manager saying that, okay, result one, hardware issue, laptop keyboard is not working, and second issue, monitor is not displaying the anything, And third matching result is mouse is unresponsive. So out of that, this is the most relevant one. So chat manager will collect that particular response, and it has given final step as okay, resolve the issue with your laptop displaying the black screen. So no, sorry, knowledge base agent is identifying the correct category or correct response from that and handing over it to the chat manager. And then we are terminating. You can see terminating the run. And then after that, okay, we are calling the notification agent, which is not available in there, because if you can see in the app.py, once this particular button is clicked, then we are calling the notification agent, and that notification agent is hitting to the tool that we have. So that how the conversation is happening, different conversation, and I hope it became very clear for you. Let's try one more example, and then we'll see whether it is working or not. So how can I report a phishing email? Let's see. Something different. I'm not sure whether we have covered this or not into our data set, but let's say if user want to report the phishing email, what is the standard way of doing that? So again, it has started the backend conversation between the agent and okay, you can see to report a phishing email, please forward the suspected email to uh, fishalert@company.com and also notify your manager about the incident. Okay, done. Issue is resolved. Great. We are glad your issue is resolved. Thank you. So yeah, I hope this was helpful, and we have built a complete end-to-end multi-agent project. I know it was a bit a lengthy video, but in order to build the real-time project, it takes time, and I have put in a lot of effort in collecting all these material, then writing this code line by line. It took me a lot of time in order to come up with this final code and workflow, also come up with this beautiful UI. So I hope this was helpful for you. We have tried building a story. What is the real-time use case? How we can solve, what is the real-time problem statement? How we can solve that problem statement using the multi-agent framework. And also we have we have leveraged a popular framework called AutoGen. So if you are having any doubt related to the AutoGen framework or related to this project, please drop me down in the comment section. I'll be uploading all this particular code into my GitHub. So everything will be open for you guys. Go ahead, clone that particular repo and try it out on your local machine so that you will be getting a hands-on experience on that. And feel free to put this project into your resume. And please let me know if this project is helping you. So yeah, that's it from my side. Thank you so much for watching this video till the end. Like the video, subscribe to my YouTube channel iTech, and for more videos, please stay tuned. Thank you so much.